This is a Chapter 8 review for 3rd grade. It is on understanding fractions. So there's a few big ideas. One of the first big ideas is that a fraction is naming parts of a whole or parts of a group. So if I were to have a whole amount here, like pretend it's an apple, and I cut it into 4 parts, I name it by the number of parts or the size of the part. And since there are 4 pieces, it is called a 4th sized part. If I want to start naming pieces out of the whole, like if I cut this apple and I want to take one of those pieces, the numerator, the top number, is how many I'm taking or what I'm talking about, and the denominator, the bottom number, is the size of the part or how many parts there are. There are 4, so I would name this fraction as 1/4 or 1 out of 4. If I wanted to take more of the apple, so I'm taking 2 of the pieces, I would name it as 2/4, so 2 out of 4. If I took 3 pieces, I would name it 3/4. So you should start seeing that the bottom number, the denominator, does not change. That is the size of the part or how many total pieces there are. That's always a 4th for this one. I could even take all of it. I could take 4 pieces out of the 4 parts, and you should see that the 4 out of 4 is going to be representing the entire amount, one whole. So when you have an object like this, it's also cut into 4 pieces, but they're not equal sized pieces, so I can't really name it, I can't compare it, I can't use it. Even if I shaded one of the parts of it, that's not 1/4 of the whole amount because they're not equally cut pieces. So big idea, when you have fractions or when you're cutting up things, they have to be equal sized parts. Next big idea is unit fractions. So if I had a huge tray and I have little sections for fruit, and I have strawberries, bananas, apples, and they're all cut up into their little sections, and they're all equally sized sections, I could name a unit fraction by one of those parts. So if I want to talk about the strawberries and they fill up one part of the whole, that would be 1 out of, or 1 out of however many parts there are. So then I would just count how many pieces there are. There's 16, so that would be a 16th sized piece or a 16th sized part. That is my denominator. For unit fractions, the unit fraction always stays 1 out of the amount. It's a unit, it's 1. Another big idea is how do we name the fractions? This is also pretty obvious when you just look at it. So if I cut something in half, I've got 2 pieces, those are halves. Thirds is cut into 3. 4ths is 4 parts, 5ths, and so on. So if I want to have like a giant pizza and I want to cut it into 20 equally sized pieces, and then I take one, I would have 1/20th of the pizza. So the denominator, the bottom number, is the size of the part or how many you're cutting it into. The numerator is how much you're taking or what you're talking about. Also part of equal shares is splitting up food or splitting up things between a certain number of people. So there's a video about this as well. It's kind of a fun at-home activity that you can do with food. But our question is 5 people share 3 oranges. We want to model this. You could draw circles. I like doing squares and rectangles because they're easier to cut. So I'm going to represent my oranges as rectangles. So I have my 3 oranges. If 5 people are going to share it, I think, well, I can't have a person take a whole orange because there wouldn't be enough. If I cut it in half, that's 2, 4, 6, that's 6 pieces. That's not going to be an even. I'm going to have a leftover piece. So how am I going to cut these so that 5 people get an equal amount? So one strategy is I cut each item into the 5 parts. So I would cut this one, 1, 2, 3, into 5 parts. So once I cut all the food into the 5 parts, then what I can say is, all right, this person, one person can take one from each piece. So if one person comes and they take one from here, and one from here, that's one person. They're getting how many parts? They're getting 3. And what's the size of the part? It's a 1, 2, 3, 4, 5th. It's a 5th sized part. So they're getting 3/5. And does that work evenly? So that one person will get those ones. The second person in the group, they're going to come and get a piece. And the last person will also get 3/5. So this kind of problem, model what you have first. You have 3 items, split it into the number of people that are sharing it, so you're going to divide it up, and then a person takes from each one, so they're getting 3 out of the 5 possible parts. The denominator is probably going to be the most challenging, and again, when you think of that, it's what is the size of the piece that we are cutting it up into. Okay, now we're talking about fractions of a whole. So for example, if I have a pizza, there are this many pieces that are left. So the red shaded ones are how many are left, and these empty ones are how many pieces have been eaten. The way that I ask my question determines how I name this fraction. So if my question was, how many pieces of pizza are there? Well, I would say there are 4 pieces, so it would be 4 out of however many parts there were altogether. How many were there to start with? There were 6 pieces to start with, so it would be 4/6. If I asked my question, how many pieces of pizza were eaten, then the part I'm talking about are the missing pieces, and how many of those are there? That would be 2. 2 out of the 6. And so you can see that the denominator, again, is the size of the part, or how many pieces there are. That's 6. The top number, the numerator, is what I'm talking about. And sometimes the question asks for what's there. Sometimes it asks for what's left. So that's where the word problems, where you have to understand what it's asking you for. I could shade in 3 of these. And if I said, what fraction of the rectangle is red? What fraction means how much of it is red compared to the whole amount. A fraction doesn't ever give you a number. It's a comparison between a part you're talking about and between the whole amount. So for this one, the part I'm talking about is red. That's 3. The denominator, how many there are altogether, is 3, 4, 5, 6, 7. There are 8. So this would be 3/8. If I shaded more, then my numerator would change. It's still an 1/8 sized part. I'm just changing how much I'm talking about. Now I'm talking about 5 out of the 8, so it would be 5/8. So that's another big idea. Numerator names the part that you're talking about. It depends on the question. Usually if it's just a model without any question, it's the part that's shaded. And then the denominator is how many total parts there are, or how many there are in the whole group. The next big idea is, how do we talk about fractions on a number line? So this is useful when we're talking about distances, like say you're going to school and you know that school is a mile away, and you want to say, well, I'm halfway to school, or I'm 3/4 of the way to school, or however you want to name it. It can be any name that you want, as long as you're representing the part correctly on a number line. So if I know that what it's asking me for is to put a mark on 3/4, the denominator tells me that's how I'm going to divide up my number line into 4th sized pieces. So here's about the middle, and there's 1, and there. So then if I label it, so this is 0 out of 4, that's not going anywhere. 1 part, this is 1 out of 4, 2 out of 4, 3 out of 4, and 1 whole is the same as saying 4 out of 4. It's the whole amount. So now if I want to put a mark on 3/4, then I know that I go to my 3/4, and that's where I am. So you can visually see it's more than halfway. It's 3/4 of the way there. If I have another number line, it's still 1 mile, but what if I want to name this in a different fraction? What if I want to say, I want to go 7/8 of the way. So if I have 7/8, put it right here. Now it's still 1 mile, but I'm going to break it into 8-sized parts so that I can name them correctly. So now I'm going to still have my halfway, okay? And they should be equally spaced parts. So this is 0 out of 8, 1 out of 8. And then one whole amount is 8 out of 8. So same thing, it's still 1. I'm just choosing how I want to divide it up. And my denominator, my bottom number, tells me how I'm breaking apart my number line. Let's say at a school, you're running laps, and every lap is part of a distance, but you need to run 8 laps to make a mile. So you run around 1 lap. That's 1 out of the 8. 2 laps, 3 laps. When you get to 8 laps that you've run around, that's 1 mile. So let's say you've only done 7/8 of the way, then you've done 7 laps, and that's how far you are on the number line. Okay, this section is relating fractions and whole amounts. So let's say I have a distance I'm going, and I've gone 1/4 of the way, all the way to the whole amount. I'm there, a certain distance. What if I want to keep going? So how would I name this if I go beyond 1 whole? Well, I'm labeling my parts 1, 2, 3, 4. This would be 5 out of the 4, 6 out of the 4. What's happening with the numerator is that it's getting larger, more than the denominator. That is a huge clue that we are over 1. We're more than 1. So when the numerator and the denominator are the same, that means we have all of the parts out of all the parts that are possible. When we go beyond it, we're saying we're having extra, so it's more than 1. So you can also see that when we're talking about how do we name things that are greater than 1. So we still want to represent this as a fraction. How do we do that? So first, just by knowing the definition of numerator and denominator, that's going to help you a lot. So numerator is the part that we're talking about. So if I shade all of these parts, how many is that? That's 4 parts, so that's my numerator. The denominator is what is the size of the part, or how am I splitting it? So if I look at one, how am I cutting it up? I'm cutting it in half. So there's 2 parts. So my denominator is going to be a half-sized piece. So my denominator is 2. And that might feel kind of weird at first, because why is the numerator larger than the denominator? But what you're showing is basically division. And what is 4 divided by 2? That's 2. And what do we see here? We see 2 whole amounts. So 2 wholes. Okay. What if I changed this and I wanted to do that? Now my numerator and my denominator change. So it's still 2 wholes, but how do I represent the numerator? It's how many parts are shaded, what I'm talking about. So there's 4 and 4, that's 8 parts. And what is the size of the part? Here's the big help when you're not sure what to put as the denominator. You go back to the one image and you're like, well, what did they cut it into? What's the size of that part? It's a 4th sized part. It's cut into 4s. So my denominator is 4. And if you look at the math at the division, what is 8 divided by 4? It's 2 wholes. So I can keep doing this as much as I want. If I want to cut this again, as long as they're equally sized cuts, if I do this and I do this, how many do I have as my numerator and how many as my denominator? Now I have 2, 4, 6, 8, and 8. I have 16 parts that I'm talking about. And what is the size of the part? How did I cut it into pieces? I cut it into an 8th sized piece. So my denominator is 8. And again, if you look at the math, 16 divided by 8 is 2. Okay, one more example talking about fractions and whole amounts. So if I need to name this as a fraction, first I need to show what parts am I talking about. So I'll shade in the parts that I'm talking about. Okay, then I add up all of my parts, 3, 6, 9, 12. I have 12 parts that I'm shading, so that is my numerator. So I have 12. The denominator is what is the size of the part. So I go back to 1 and I say, well, how did I split this up? What is the size of this piece? It is cut into thirds, so it's a 3rd sized piece. which means my denominator is going to be 3. So this type of fraction, we call it a fraction greater than 1 because the numerator is bigger than the denominator. We also call it an improper fraction. And again, if you think of it as division, what will happen if we do 12 divided by 3? How many wholes are there? Well, you should see that there are 4. So if I divide it, I get 4. And if I look at it, I see that there's 4 whole amounts. Same with this one. First, you have to shade in the parts that you're talking about. So how many parts are shaded? 4, 8, 12. There's 16 parts that are shaded. So that is going to be my numerator is how many I'm talking about. The denominator is what is the size of the part. It's a 4th sized piece. It's cut into 4 parts. So my denominator will be 4. And then if I think of it, what is that? What do I see? I see 4 whole amounts. And if I know my division, what is 16 divided by 4? That is going to be 4 as well. So that's how it's all related. Okay, the next part is talking about fractions of a group. So there's 2 ways you can visualize that. What it's telling you is, depends on the question actually. So if I said, what fraction of these marbles are blue? Then the part that I'm asking about is the blue ones. So I count the number of blue ones, 2, 4, there are 5. That's my numerator because it's how much I'm asking about. And what fraction of them are blue? That means the denominator is how many are there all together. So 5, 6, 7, 8, 9, 10. So there's 10 all together. So what fraction are blue? 5/10. If I said what fraction are red, then I would count the red ones. How many red ones are there? There's 2. So my fraction would be 2. And then how many are there all together? There's still 10. So my denominator would be 10. 2/10. If I said, what fraction of the marbles are green? I would just look at the green ones. There's 3 that are green. Out of how many? Out of 10. So out of 10. So again, the denominator is how many there are, the whole amount, and the numerator is the part, okay? We can also think of this as chunking it together. So if I said, what fraction of the group is green, I don't need to talk about the individual parts anymore. I can say as a group, there's 4 containers. So there would be 4 containers. And what part of it is green? One of them, 1 out of the 4 would be green. So you could still talk about the individual pieces. What would that be? If I said 3, there's 3 green ones. Out of how many? 3, 6, 9, 12. Out of 12. That works too. You could do that. So it depends on the question. But if you see them grouped, you can say 1 out of all of the groups. Okay, same thing when you're going more than 1, when you have items and it's not actually cut into pieces, you can use the same idea. So if I'm talking about how many racquetballs are in each container, there are 6 of them. So there's 6. And if I want to know the denominator, that is how many are in one of them. So there's 3 in here. So my denominator would be 3. And again, if I were to do the division, 6 divided by 3, that gives me 2 wholes. So same for this. Say I have some sheets of stickers. So here's a sheet, and each sheet has 4 stickers on them. So I'm talking about the stickers, 4, 8, 12. So there's 12 stickers. How do I know what the denominator is? I go back to my one part and I say, well, how many are in here? So kind of the same as fractions. What is the size of the piece? But if I'm talking about items, I go and say, well, how many are in one of them? That's my denominator. There's 4 here. So it will be 12/4. And again, if I do my division, 12 divided by 4 gives me my 3 whole amounts. Okay, this section is finding part of a group using fractions. So if I get a word problem and it says 1/5 of the chocolate in a box of See's candy has almonds. and I want to know how many pieces is that. And I have 20 pieces all together. How much is 1/5 of that amount? So when you do these kinds of problems, you want to always model it, and you model starting with how much you have. So I'm going to model my 20 pieces of chocolate. And my denominator tells me how many groups I'm going to have. So 1 out of the 5 groups. So first I need to cut up my 20 into 5 groups. So let's see, if I do it like this, there's 1 group. Okay, there's 5 groups. So the denominator is how many groups? My 1 out of 5 means I'm talking about 1 out of those 5 groups. So I have 5 groups. I want to say one of them, so one of them is just one group. And how many are in that one group? So there's 1, 2, 3, 4. There are 4 pieces of candy, or 4 pieces. So 1/5 of 20 is 4. And if I think of that back to like a word problem, so I have a box of candy, there's 20 pieces of chocolate in it. And I'm saying 1/5 of the chocolate has almonds. 1/5 is not the amount. That's not, I can't eat and like pick up a piece of chocolate and say, oh, here's 1/5. 1/5 is a comparison between a part and a whole amount. So 1/5 means 1 out of the 5 parts, all of these 4 are going to have almonds in them, because that's what I'm describing. What if I had 1/8 of 16? So this can relate to any kind of word problem. Let's say I have 16 Lego sets, and 1/8 of them are Star Wars. So I want to know how many is that. So I have 16, so I want to first model my 16 Lego sets. And then when I look at my fraction, my denominator tells us the number of groups. How many groups will I split this into? So I'm going to split it into 8 groups. So depending on how you draw your dots, it's okay if it's kind of unorganized as long as you have 8 clear groups and they are even and equal groups. So 8 groups, so there's 1. So now I have my 8 groups. What this fraction is telling me is 1 out of those 8 groups. So 1 out of the 8, how many are in there? There's 2. So I would say out of my 16 Lego sets, 1/8 of them would mean that 2 of them are going to be Star Wars. So there's 2. As you look at the math up here, you will start to see some patterns, and you might be able to jump ahead and kind of know what to do without drawing a model. But the model is always good to fall back on and use as a strategy in case you get stuck and you don't know what to do. Model it and then start talking yourself through the problem. So this is finding part of a group. Then you have finding the whole amount. So that's the next part. This is the last lesson of the chapter. These questions are longer and it's problem solving, so you have to read the question a couple of times to really understand what it's asking you for. So Miss Khatib had 4 purple scarves. This is 1/6 of the number of scarves. How many scarves does she have altogether? So with these kinds of questions, there are 2 pieces of information that talk about the same thing. First, we have to ask ourselves, what are we looking for in the question? The question is asking us, how many scarves does she have altogether? What do I have? What information do I have? I know that I have 4 purple scarves. So 4 scarves are purple. What else do I know? That this is 1/6 of the number of scarves. So 4 scarves are purple. The purple scarves is 1/6 of the whole amount. So what do I do with that information? So whenever I'm seeing a fraction, I want to just write it down so I can kind of have a visual of what I'm working with. So 1/6, 1/6. What do I do with that? Well, if I think about what the denominator and the numerator tells me, the denominator is the number of groups that I have, and 1/6 is 1 out of those groups. So if I start by drawing my groups, and then how do I know what to do next? How do I know what goes inside of it? Well, we go back to our question. So I have 4 purple scarves. So how do I know what to put in here? I'm going to put my 4 purple scarves. And then I keep checking. I always keep going back to my problem. Is it making sense? There's 4 scarves in here. This is 1 out of the 6 groups that I have. So then what I have next is I just need to fill in the rest of my scarves. And it doesn't matter what color they are. I don't know. They could all be the same color. They could all be different colors. But I do know that I have 4 in each one. And if I add all of this together, what I have is 4, 8, 12, 16, 20, and 24 scarves all together. So, and then I go back and I keep checking, is this making sense? So I go back to my problem, 4 purple scarves, there's my 4 scarves. This is 1/6 of the total scarves, so this is 1 group out of the 6. Yes, that makes sense. And I have 24 altogether, so it all works out. So this is the last lesson in the chapter. If you are struggling with any of the topics, you can go back and search up videos that are specific to each lesson. In the description, I'll try to match the lesson number and the name so that you can figure out which part you need extra help on. Hopefully this helps to give you an overview of the whole chapter. Again, the hardest part will be the word problems. So when you're reading a word problem, sometimes it's good to just ignore the fraction part of it and just understand what the question is asking you, and then start putting some of the numbers back in. So thank you for watching, and that's it.